Okay, we have the answer key for the separation of variables assignment now. Okay, so the first couple, we're just writing a differential equation. That's our goal, to write a differential equation. So we need to break down what's told to us in the initial part. So we have the population of the bacteria B in a petri dish will grow over time at a rate which is inversely proportional to the current population. Okay, so population is growing. That means the population is changing. So it's changing, the population is in terms of B and changing over time, which means we have dB dt, okay, which is, there's our equal sign, inversely proportional. So that means we're going to have some kind of coefficient k or constant k over whatever the differential equation is inversely proportional to, and that's the current population. The current population is B, so it's K over B. That's our answer. Inversely proportional means we have K over, and inversely proportional to what? Current population, so therefore B. Okay, another one of these, rate of change of volume of water in a tank with respect to time is directly proportional to the square of the volume. Okay, rate of change of the volume, dV, with respect to time, dt, is directly proportional. Directly proportional means K times what? K times the square of the volume, V squared. Alright, and once again, we are done. Okay, I did not have a chance to go over this one in class, but I'll work it right now. Population is growing according to the differential equation, dy dt is equal to ky. Okay, now in class we did briefly talk about the fact that if the derivative is equal to the original function times the coefficient, then that means that we have exponential growth. Okay, so in this case, this right here is telling us that our population, I'm going to use, well, alright, I'll use y. Y is equal to some initial population times e to the kt. Okay, and the reason why we know that is because if we derive this, then we have the coefficient, which stays, and then e to the ugly derives to itself times the derivative of the exponent, times the derivative of the inner function. The derivative of kt is just going to be k. Alright, so look at this, c e to the kt. We know that this is right up here, and it's equal to y. So by substitution, dy dt is equal to y, instead of this, times k. Or if you prefer, we can put the k first. Alright, so this is our initial function right here. Alright, now what do we know about this function? Well, it's our population, and it triples every 20 years. Alright, so let's just think about this for a second. Let's say that the population at time 0 is 100 people. Okay? Well, that means that 20 years from now, alright, so y evaluated at 20, it will triple. What's 100 tripled? Exactly, 300. Okay. However, if we plug 20 into, well, alright, let's time out. So we got that so far. Okay, so just keep that in mind. Alright, now let's go back to the y of 0. If we have y of 0, and we plug that into our function, alright, that's going to be c times e to the k times 0. So k times 0 is 0, and e to the 0, in fact, anything to the 0 power is what number? Exactly, it's 1. So this is c times 1, which is just c. So y of 0 is just c, but we know that y of 0 is 100, so we're just going to make c equal to 100. Okay, so what does that mean? That means that y is equal to 100 e to the kt. So if I want y evaluated at 20, then I have 100 times e to the 20k. I'm replacing t with 20. So y of 20 is 100 e to the 20k. However, y of 20 is also 300. Alright, so we can set them equal to each other. Now, we want to solve for k. Well, we would start by dividing by 100. All right, and we see that we have e to the 20k is equal to 3. And in fact, that's why it didn't matter what the initial population was, because whether this is 100 or 1,000, well, that'll just be 300 or 3,000. And those numbers always fall here, and you always do the larger divided by the smaller, and it always comes out to 3. Our goal is still to get k all by itself. We have to get rid of the e, which means we have to take the natural log of both sides. All right, so now, natural log of e, they wipe each other out, and we have 20k. That's equal to the natural log of 3. And that means that k is equal to the natural log of 3 over 20, which we can use our calculator to figure out. Now here's the deal. On the test, on the quiz, this will be a bonus question because we didn't go over it in class. But the shortcut for finding k is just going to be to do the natural log of the growth rate. All right, so if it's tripling, then we put a 3. If it's doubling, we put a 2. If it's quadrupling, we put a 4. And you divide that by the number of years it takes for that population to grow. In this case, it's every 20 years. That's why we have 20 in the bottom. The quick form is the natural log of the rate divided by the number of years. That will give you k.